This is the second part of the phase diagram video. So now instead of pressure composition phase diagrams, we have a temperature composition phase diagrams where you have temperature instead of pressure on the y-axis, and on the x-axis you still have the mole fraction of A. At low temperatures, the two components coexist in a liquid phase, while at high temperatures everything is in the vapor phase. And we are talking about an ideal mixture with two liquids, both of which are volatile, but one is more volatile than the other. So let's say we start at this composition, let's call it ZA1, and we start heating the liquid. At this point, we reach the boiling point of the liquid at this composition, ZA1, and then the first vapor starts to appear as the temperature is kept constant. If you were to take off this vapor and then condense it, then you would form a liquid of a different composition, let's say ZA2. Now this liquid has a higher percentage or a higher mole fraction of A than what we started off with. One can repeat the process. One can again start heating. This was the cooling phase where you condense the liquid, and you can keep repeating the process and keep getting liquid with a higher and higher composition of A until you get pure A. This is the case when you have an ideal mixture of two components. In case you have non-ideality, and we will cover this in class, we have what is called an azeotrope, where you cannot separate the two liquids any further. So this process of repeated heating and cooling is called fractional distillation. And your first laboratory will deal with fractional distillation to try to understand the extent of non-ideality in a two liquid mixture.